Welcome back to the Professor's Du Bois channel. I hope you are having a great day. Today we're going to be talking about compound stoichiometry as we continue our General Chemistry 1 lecture series. Let's go. What's compound stoichiometry? That's a strange word, stoichiometry, isn't it?
And it's really hard to spell.
It is.
So why, chemists did so many things to make things easier until we get to stoichiometry.
Right.
Okay, but really, stoichiometry isn't that hard. This is my definition of stoichiometry. My definition is we're going to go from moles of one thing to moles of something else. That's stoichiometry. So today we're going to focus on compounds and how we can convert from moles of something in a compound to moles of something else in a compound.
Right. So we're going to start out with this compound iron sulfate.
Iron 2 sulfate.
Iron 2 sulfate,
Polyvalent.
right? Yes, because iron can be iron 2 or iron 3. So we're going to have iron 2 sulfate, and we want to think about what are the factors or the mole-mole ratios within this formula. And there are many, actually. So if you look at just the formula, you can see that there's 1 iron for every 1 sulfur. And we have 1 iron for every 4 oxygen. So this is actually an oxygen, not a 40.
It looks like a 40.
It looks like a 40.
It's 4 oxygens.
Right. And there are many, many, many other ratios within that one formula. So we can have, for every 1 entire FeSO4, we have 4 oxygens, or 1 sulfur, or 1 iron. So we can use these factors as we need to as we're doing our conversion. So an example of a question that you might see is how many moles of oxygen are in 3 moles of iron 2 sulfate? And you're going to start with what you know that's not the factor, which is the 3 moles of iron sulfate. We know we need to cancel moles of iron sulfate, and we put that in the denominator. Now notice that we're adding what the species is here, because we're going to be using the mole-mole ratio to convert from one thing to another. And we're going to have to go through moles for that. So here we're going to cancel moles of iron 2 sulfate, and we're going to use our conversion factor of 4 to 1 to get the moles of oxygen. And that's compound stoichiometry.
So we use this idea of a mole island, and it's not our idea. You'll find this all over the place. But mole island is kind of it's kind of a visual representation of what's going on, and it kind of allows you to make a roadmap to do these conversions, because they get a little confusing sometimes. So sometimes it's nice to just have a visual roadmap that you can follow to help you with these calculations. So let's show them Mole Island. Okay, so you can use Mole Island. We're going to be using this all throughout the whole General Chemistry 1 and actually General Chemistry 2. So this is a very good thing to make sure that you understand. And if you like it, use it. If not, you can just cancel units. But it's the only place where you can change from one thing to another, from carbon to hydrogen, from methane to carbon, whatever. If you have information about one thing and you need information about another, that's when you know you have to go to Mole Island. So here's an example. So if the known and the unknown are a single material, you have the molecules of hydrogen and you need the moles of hydrogen, you can just use your conversion factors like we've shown you before. But if you have to change the identity of what you have, your known, and your unknown, these are different species, then you have to go to Mole Island. So here's our example here. So if you're given grams of A, so here's our compound A, B, and we have three B's to 1 A. This is our formula. If you have grams of A, you can go to moles of A. We taught you that using the molar mass. Here's the trick. Here's the compound stoichiometry right here in the middle. You can use moles of A to get to moles of B because you have this formula. You know it's a 3 to 1 ratio from your formula. So you can convert to moles of what you're looking for, which was B, and then you can get back off to grams or molecules or atoms, whatever it is that you're looking for. Well, in that case, it would be atoms, wouldn't it? Here's an example. So an example, we have grams of CH4, and the question wants to know how many atoms of hydrogen. So this is a situation where we're going from one thing to another, and we're going to, we'll use the Mole Island. You don't have to use Mole Island, but we could make a little roadmap here. We're going to start with grams of CH4. That's what we have. And we're going to use the molar mass of CH4 to get onto this mole island. And once we're on Mole Island, we're going to use compound stoichiometry, or we can use the ratio of 1 mole of CH4 is equal to 4 moles of hydrogen. Got that right from the formula. And then from moles of hydrogen, we can use Avogadro's number to then get to the atoms of hydrogen. So this is kind of showing you how we're going to walk through this calculation. A lot of people find this useful. Some people can live without it. So I'm going to start with my 1.604 grams of CH4. I would put it over 1, and then I'd immediately write grams in the denominator of my first fraction. And so this is my molar mass of CH4, the 16.04. So I've converted to moles of CH4 in the first step. In the second step, I'm on Mole Island, and I'm going from moles of CH4 to moles of hydrogen. And that's a 4-to-1 ratio. There's 4 hydrogens in every 1 CH4. So now I have my moles of hydrogen. I'm going to use Avogadro's number to go to atoms from moles. So big, long calculation. The way I would do this is I would just ignore the ones. I would go 1.604 divided by 16.04 equals times 4 equals times 6.022 times 10 to the 23rd. Many ways you could do this, though. You could multiply all your numerators, multiply all your denominators, and then divide. Do whatever works for you. Make sure you can get this number. If a common mistake is putting the scientific notation into the calculator incorrectly, so make sure you know how to do that.
Practice that for sure. All right, pause the video and practice this. All of these different questions, you have the information to solve at this point. So we showed you how to calculate the molar mass in the last video. So use your formula. This is 2 hydrogens, 2 carbons, and 4 oxygens. Add all of those up, the masses on the periodic table, that's your molar mass. Using the molar mass, you then can convert grams to moles. From moles, you can calculate, this is the same number of grams, so this is then would be a 2-step, from grams to moles, then moles to molecules using Avogadro's number. And then this is the compound stoichiometry that we just taught you. So you'll have to go from grams of oxalic acid to moles of oxalic acid, get onto Mole Island, use your mole-mole ratio, how many carbons are in 1 oxalic acid. So you'll have 1 oxalic acid compared to, I'm just going to say OA because I'm lazy, I guess.
Okay.
And we have 4, no, we're doing
Carbon.
2
carbons.
2 moles of carbon. So try that. We'll give you the answers.
Just a second.
There's the answers. Hopefully you did well. So practice this. Practice, and use our other videos to help you. We have some other practice videos out there. And thank you so much for watching. And we will be right back with another lecture. Continue on.
Stay tuned.
Stay tuned. Bye-bye.